möchte gleich beginnen.
And I would like to start with an overview where the business side, the economic side, plays an important role. We did research the BIMA strategy end. We have a connected car report here, and it says that 2030, more than 1/3 of the profile will go through shared mobility, digital services, new technologies. That's how we generate profit. And not only the traditional OEMs will participate, but new players like mobile, NVIDIA, and other companies we already have heard about this morning, sometimes with systems which are optimized by Bosch, NVIDIA, for example, the graphic processors. And so these new players, of course, will play a major role. And when you look at it, and this is also a result of strategy, and more will be done in partnerships and through acquisitions. So the traditional segmentization, we have OEM in Taiwan and a few suppliers, that will be dissolved. There will be new collaborations in new technologies, and Günther already said connectivity and cloud services. This is the money-making machine, because the mobility is driven by services from the cloud, or clouds will give us the technology in order to realize new services, new business models, and to understand how the customer then processes it. And so the cars will be connected, but mostly connected to the cloud, whether these are series vehicles or specialized, customized one, that doesn't matter. But for ETAS, connectivity, cloud services, car-to-car communication, that is a very important issue we look into. And one important thing that we have learned, cloud development, cloud services, it is for us a given thing that we get new software components, new apps, new updated versions of apps every day, every hour, basically.
Safety, security is commodity.
Safety is a commodity. Nobody wants to know whether a computer is really protected against bugs. My assumption is, of course, that it is protected. I don't want to see it crash just because a bug got onto it. So I expect from the manufacturer of the software, of course, that it will not crash. I don't want to have to worry about whether the vehicle is safe or not. It has to be safe. It's my expectation.
Wenn wir jetzt sozusagen auf die Seite der Embedded-Systeme schauen,
If we now look to the embedded systems, there are different platforms, Windows and Linux environments, for example. There's the cloud and other ecosystems. A lot of systems, in short, which for some OEMs and even Tier 1 suppliers might be new. Well, we're just growing accustomed to them, actually. So let me just talk about adaptive AutoSAR. So we expect that regarding software update and that possibility, that the standards will be put in place for that, first of all, so the groundwork is done. So if we look at the vehicle data, then you might be interested to know that these are categorized by which one are private data, which are data which have to do with components, which are data that need to be exchanged globally, for example, to inform or to even prevent a traffic jam situation, as the one you can see here. And there's also a need for some standardization to ensure that all the road users can benefit from this information. What is important is that we should always be aware that we're part of a globally distributed environment. For example, if we do test rides in the US, in Europe, in Asia, then we expect that all the data can be consolidated and analyzed centrally. But the infrastructure for that needs to be put in place first. Now, I also said that when I talked about connectivity solutions, that there was an interesting new development, new since 2016, 5G AA. So it seems as though, as this only had to do with 5G, however, if you look closer, you can see that it wants to do more. It wants to create development solutions. And you want to make sure that these solutions are available commercially, and I find this particularly interesting, that this will also address the needs of society. What shouldn't happen is that, a certain vendor has access to some networks, other vendors don't have this access. That is why, one will be less safe than the other. I think that would be socially unacceptable, so you have to reconcile that somehow. And thanks to these efforts towards standardization, this is precisely what will happen. The focus clearly is on autonomous driving and also on ubiquitous access to services. However, it goes beyond that. It's even about the integration into smart city. So really, our aspiration is global.
Ich will gar nicht auf alles eingehen, ich will nur ein paar Dinge herausgreifen.
I'm not going to take you through all of them, but we have to actually learn how to work with these things. DevOps, for example, the cloud, or the change from prescriptive to predictive maintenance. We want to be able to do more prevention, not just describe what the area was like, what the ambient conditions were like. Rather, we want to be able to predict when the car will have to be taken to the workshop, software updates will have to be performed. So it's all of these new things that will be important. We heard a lot about neural networks, for example. Software updates will loom large too. And there's one thing that's important for me personally, so let me come back to that, the ODS as the standard for the storing and exchanging of measurement data and metadata. This morning we heard data are the new oil, but when will they really be the new oil? Well, you can only use them if you know the context in which these data were gathered. Only if you have that, you can really, create some value from it, really. And we, as part of a project, are heading a project here in this field at the moment.
Also 5G hattest du ja vorher schon
Now
reingeworfen.
5G, as you said, security, quite a few things happening on that front. However, other technologies are important too. For example, what we have in the car inside. 5G is nice to have, but of course there are limits to that. So how do you see this? Well, we're deliberately focused on the development of back-end and embedded systems and how to connect them. Now, there's a whole range, of course, of different topics which have to do with the EE architecture, distributed intelligence, for example, or the central ECU, for example, the telecommunications ECU, which will then see to communication with the outside world. Well, I think we will see a number of new developments yet on that front. So I'm really looking forward to it. My personal guess is that adaptive AutoSAR will be an important milestone in this respect. The question is to what extent AutoSAR will become widespread. I mean, there's been a lot of controversy around this. We talked about this recently. And people, of course, have different opinions, but, embedded and back-end systems, if you look at these two, it's obvious that you want to offer services which are independent from the different OEMs or manufacturers. And you need to have an interface that's standardized, of course, to connect with all the different OEMs. And that is why adaptive AutoSAR standard will play an important role. Well, to add to that, I think it was on your last chart or the one before that, there was a colorful chart which represented the different tools. So, and I have a question on that. Do we have to move the tools into the cloud, or does it have nothing to do with that? Are there any synergies between the development and the use that's derived from them later on? Tomorrow there will be a presentation on AutoSAR development. And they're going to show how this can be used to drive solutions in the cloud, ISLR A configurations, how these can be made available in the cloud. Well, I think when it comes to many of these developments, we are going to need virtualization. Well, the number of tests that are needed, we cannot do this all at the level of the car. It's, of course, a nice thought that all the drivers will do these beta tests for us. But there will be a lot of virtualization, without any doubt. Earlier in the lobby, we saw the COSM demo, which is our virtualization solution. And there very clearly is a trend towards the cloud because so many things are to be connected in the future. And for that, we'll need a lot of resources in order to really, muster this gigantic computing power and to link them in a cloud system. Otherwise, we'll not be up to the task.
Ich möchte einfach kurz darstellen, was wir...
Let me briefly talk about what we as Bosch are doing jointly with respect to connected development to be extended to an end-to-end solution from development to the end of series production, and what the ideas are behind it. I should like to start with the question, why? Why are we doing this in the first place? Why? And I'm not just talking about automated driving. How's the technology, the engineering evolving? We've got a mechanical system. That was the start. Then we had the mechatronic systems, and now we are in the informatics mechatronical system. But where is the world going? The systems of systems. So the vehicle is a part of an ecosystem. We've heard that before. And to be able to generate added value with this, be it by way of maintenance or fuel consumption optimization or electrification. So this is the driving force for the development of connectivity. Connectivity is also a driver which is at the end of the data-driven business model. The question is now, what has it got to do with the topic? Because I do digital development. Nothing much at first, but if I want to become faster from development to series production, then I have to think about that I have to use the same methods in development that I want to use later on. And what methods and tools are they now? Straightforwardly, let's take a look at what this picture looks like. I've got my car. I've got a tractor here, not just cars, not just passenger cars. And I've got many ECUs and an onboard unit. Could be separate, it could be on the gateway, it doesn't matter. This sends the green data into the cloud along a complex path, and this data is then evaluated in the cloud. Okay, classically, data is green, but I didn't ask for green. I want the orange ones. So I have to have the possibility in my system, as shown here, for new algorithms in light blue and evaluation algorithms in pink to be evaluated and reconfigured, and then I can send them to my data receiving end. Very important not to work in the hot zone here, but in an area where with justifiable expense I can actually do this. And once I've done this, then it's not very far from sending the development data as well. Same tool chain, same development, and logically I can do my flashing. And I've got a good property then. I need that in development, but also in series production. To go back to the design concept, we said, okay, we've got two steps: the PLCA, product lifecycle acquisition, where we acquire data, and then PLCD, product lifecycle data management, and we come back to that in more detail later on. And now I come to our concept, very briefly. At the bottom we have the layered model. We have the layer model, and at the bottom we have the hardware boxes. The ETAS box mentioned before, which is here before SAP, is a high-performance box with which I can actually the information from the vehicle. Out in the field, we have the low-performance boxes in series production as well, on the very right here. And the art is in development that I have a consistent layer which makes it possible, which separates this hardware adaptation, and at the same time, for getting out data before and after SOP, doing the PLCA level. I send this data into the data management system, where the algorithms are processed, and I can do big data there, and then I go to series production. And here, this is the SOP world. And here at the top, this is the service side. Very important, the development side. That's what I'm focusing on today. Very briefly, series solutions, and was very important from my point of view. And we've discussed this several times before. An evaluation across the classical SOP. And this will show you that I've got a continuous change across the chain across the life cycle.
Und es ist überhaupt keine
Flashing over the air. It's not rocket science. And you can do the same with your cars. You take a hotspot and you use your Inga tool and you can do flashing over the air. The problem is an entirely different one. The problem is that you have to have the right package at the right point in time and put it on the car on the right time and make it secure. The problem is not data administration, data management, but the parameterizing of the data. That's what counts. So with a high security data transmission, because you want that data on board that you actually sent to the car, and then the flashing proper, that's state of the art. That's not a problem at all. Other example, fleet management. Fleet management in development. You may say, okay, I've got my exit table at home and then I know who actually drives my car at the moment. Quite right, but this is not what it's about. It's not about knowing where the car is. It's not about being able to contact them by phone. What it is about is getting structured measured data. So all the data positions, what's on board, what's the software, what's the status, environmental data, etc. Was there in the north or in the south? Was it raining or was it snowing? This is part of fleet management, and that's what you need for development. The metadata need to be put together with the measured data in a structured way in order to be able to evaluate this data later on in a meaningful way.
Da brauchen Sie für die Beherrschung der großen Datenmenge einen Indexer.
So what you need is the data, an indexer, and the database, of course. And you see here what it looks like. And afterwards, you can actually get your data scientists to work with the data, the billions of terabytes of data that you collected. But the other developers must be able to make meaningful use of this data, and for this you need such a tool chain, which a non-computer scientist can actually use as well.
Sodass jetzt weiterkommt zu dem Thema Web-Based Validation.
And now we come back to web-based validation. That's a service that we are offering. In development, that means to validate vehicles, in particular for components. We gave you the examples, not just for automated driving, but also for components validation, without the combination having to be removed from the car, but by using the data and the knowledge of the individual systems. And I have to know them, and then I can validate them. I can do this on a wide foundation, software applications, software functions as the basis. And what's important, at the end, I need rule-based methods. And if you go back to our start with the product life cycle, you can generate new functions with it, new rules with it, which go into the back end on the one hand, and which reflect back, and you can run them on the CCU as well.
Jetzt hört sich immer so toll an.
It always sounds so lovely. I mean, somebody said, oh, I've got terabytes of data that I collected. Now, as a physicist, I'd say, okay, this is where you start your first entropy, because you don't know what to do with this data and how to use them in the end. So the objective must be to correct the right data, the correct data, and not just transmit them. And what's very important, if from the development on the left-hand side you go into series production on the right, then you have to think about what data you can actually transmit, what you can afford to transmit with reference to bandwidth, because it all costs money. And this is why, from my point of view, in particular when it comes to the life cycle approach, across development and connectivity, on the left-hand side, we have development. It makes sense to collect a lot of data, but then when it comes to series production in series, then we use the data compression, so-called smart data, in order not to have terabytes of data, but just have very few data that you can actually use meaningfully. That brings me to the end of my presentation. This is the picture that I was showing at the beginning, reflecting our approach. Very important is to offer a solution across the entire life cycle, which is structured in a modular way from the bottom to the top. Different types of hardware, different types of data acquisition, powerful data management tools for great amount of data, but intelligent solution for small data and for the corresponding services, and to be able to make all that available.
Diese ursprünglich diskutierte Trennung.
The separation between pre-SOP, post-SOP, and looking at this picture, it doesn't really make a lot of sense to separate this. But what it's all about is you have to go it across the board. Yes, you have to do exactly that. You have to validate intelligently and use the customer's car, if of course with the agreement of the customer, to validate it, to analyze it, to validate it, and then put it into practice. Everything else doesn't make any sense. You won't get faster and you won't get better because when it comes to validation, it's no good. If you use the professional drivers who know exactly how they have to drive in order to be paid for it properly, they always drive in the optimum way. But you have to use the normal drivers, and you have to plan this into your development process. This answers the question that I was discussing with Kai Pino before. The tools in development have to be the same tools than the one that you are using at the end. Yes, it has to be consistent. The quality will go up, and the data that you have here at the front, you can actually play them back into development if needs be.
Ich beginne, später wird dann
Now,
Keller.
I will begin later on. Mr. Keller of Bosch Software Innovations is going to show you a couple of slides, and he's also going to start the live demo. Now, on the road to autonomous driving, there are a few challenges to overcome, and one important part of this challenge is the evaluation. So, making sure that the functions work there, which will then have to be approved. So it's a system that we want to bring safely to the road. And one key technology we believe at Bosch is connectivity. So that all the effort, and it's not just the mileage and the time spent really, so not just to get that right, but to ensure we have the connectivity we need.
Das heißt, wenn ein Event ausgelöst worden ist, geht
So if an event has been triggered, the data will actually pass through the entire chain here. And there are three use cases which we look at. First, the data analyst, who will then evaluate the data. They will run statistics. They will keep track of conspicuities. Then there is the fleet manager, who is in charge of planning the ride or the route and analyzes that. He can also influence, of course, the routes and change them. For example, if it's an approval ride. And then there's the developer. He too is very important for us, of course, because the data which are required for validation, which have been recorded and which have been defined beforehand, will then be analyzed in a deep dive process, as it were. Now, this approach, we already implemented it at Bosch in the Move UK project. It's a project with partners from the UK, which receives funding and has been, running since 2016. In the left, you can see the setup, the infrastructure, which we've implemented. So we've got a video camera and radar sensor. The data are transmitted through 3G or Wi-Fi. And then there's a customer cloud, and in England we have a customer cloud too. It's transmitted to that. The data we record are data such as the vehicle distance to the vehicle ahead of you, lane functions such as the automatic emergency brake, for example, assistant, but also driver behavior, for example. So the driver in the car, what is their braking style like, fast or slow? So that will be recorded too. So that is the sort of outline of Move UK. Now in the fleet we have 5 cars. We've recorded up to 50,000 miles so far, and at a space of 1 second, we record 300 signals. So, and with that, we've already built a pretty decent database, I'd say. The advantage, really, of that fleet is, and earlier in the presentation, we heard the comment, if the test drivers did the driving all the time, we wouldn't get real data. So we used, your middle-in-the-road driver, really, people from the municipality, really. Well, some of them like to drive a bit faster, and some a bit more aggressive than these test drivers we normally use. So, because of that, we get already more real-world type scenarios.
Jetzt übergebe ich an Herrn Keller, bitte.
And I'm going to hand over to my colleague, Mr. Keller, here. Well, today I'd like to give you a peek behind the scenes, the EIT. So what does it take to implement a project? At Bosch Software Innovations in 2012, we started to look at this field data exploration. And we have built a software which has already been revised. We've got the second release now. So we've been able to offer it since March 2016, and it runs on the Bosch IoT Cloud.
Unsere Software ist eigentlich genau dieser Kasten hier, dieses Systematic.
Our software is this box here, the Systematic Field Data Explorer. So from wherever we are, we can simply accept data. So for us, it's not important whether we source the data from a car, for example, directly, or whether it's aggregated data from an FTP server, for example, or an OEM. In this case, of course, the OEM will first gather the data and then transmit some of the data which are relevant to us, so data which are intended for Bosch.
Des Weiteren haben wir natürlich auch die Möglichkeit über ein Query API.
In the Query API, we can offer also the same thing as with the Query UI. In other words, third-party tools, MATLAB, Tableau, or other elements, or Excel, for example. So you can extract the data anytime they are live from the platform. However, this will also mean that all of this information will have to be available on the internet. But of course, this will also have implications on security.
Im Move UK Projekt war es jetzt so, dass wir eben
Then in the Move UK project, well, we've gathered all the data, and then for the in-depth analysis, we've also transmitted the data to the ECM system by ATOS for a more in-depth analysis, because it offers more possibilities.
Wir haben auf der SFD-Plattform ein paar generelle Funktionen.
We have a couple of more generic functions here, the Query UI, for example. Then we have a data browser, which is very simple. Now, at this stage, we only want to check whether data have come in at all and what these data look like. So all this function does it wants to look at what's inside. Then there's the data analyzer, and you can see the MongoDB aggregation framework. Well, here, if you're a technical expert enough to enter it and to then execute it, and you'll get your result promptly, you can do a CSV export or other things. And there's a third possibility, there's something that we've introduced since this year, is the Data Explorer. So this one is based precisely on the data analyzer. Only here we have the possibility to show predefined fields. So at this point, you can say, okay, I'm interested in this time period and this tour with a certain serial number. And all this is basically our template functions. So in theory, you could change it here to what about the query? What fields do I need for the query? Do I want these fields to be optional? Such things can be done here.
Bevor man die Eingaben dann manuell durchführen muss, haben wir im Move UK spezielle
In the Move UK, we've defined use cases so you don't have to input so much data manually.
analysieren möchte.
So it's already defined. So let me show you the overview.
Wo ist das Fahrzeug?
Here you can see where the vehicle is. You can zoom in. You can see the tours that have been performed in the previous days and how many cars there are. Then we can go to a tour view where you can make a selection from when until when, for example. Then the vehicles you want to look at, and you get a quick selection without having to look at the query as you just saw from my colleague here. So, and then we'll be shown that's a real tour.
Und hier sieht man auch, dass es live ist. Also
And you can see that this is truly live. So we are now on the cloud, on our Bosch IoT cloud, that is. Now at the top left, in the dashboard, you can see the sequence, then the tour on an overview map. And there's also an analysis option here to explore your data. Now, it's a bit shaky here because we're really live here. It's through the internet. You can see the dot, that's the vehicle. These are the second data. So we sample data every second, and then there's a break maneuver. It's a test brake maneuver. There's a traffic sign, and then you can see how we navigate our way through here. If we go to the starting point of the emergency action, you can see the brake pressure. So that goes up, and also acceleration. And we've defined such events. They've been implemented in the car, and the whole chain, which I talked about earlier, up to this view, has all been fully implemented. Now, in the near future, we are going to add more sensors. And we're also going to define more use cases, which you'll be able to see here.